Hello dear students, welcome to Pen and Paper Chemistry. I hope your pen and notebook are ready to take down notes for offline reference as we continue with the topic of carboxylic acids in this video. We have been covering the properties of carboxylic acids with the help of this flow chart that you see. And such flow charts are available for all the other topics on the channel as well. So for example, alcohols, alkenes, alkanes, alkynes, all of the topics have been covered with the help of these flow charts. Now we've already covered the properties of COOH group involving decarboxylation, that means removal of the COOH group. Also reduction have been covered already. In today's lesson, we are going to talk about the properties of the OH group, connecting our learning to the properties of the OH group as we have observed in the case of alcohols, and the other most important characteristic of carboxylic acids, that is the acidic character. As I always say, please make sure that you have your pen and paper ready with you so that you can take down notes for offline reference. When we talk about the properties of the OH group, now we will connect it to our learning in alcohol. C2H5OH plus PCl3, phosphorus trichloride. Alcohols with phosphorus pentachloride, alcohols with sulfonyl chloride. Why don't you try completing these reactions on your own so that it's a good revision for you, plus you will be able to correlate your learning to carboxylic acids. Also, you can keep the flow chart handy. As you can see, I've kept it on the right side of my screen. So you can similarly keep the flow chart handy while you are learning this lesson to write down the equations. Pause the video, try it please. So in the case of alcohols, we had written the reaction and we had completed them as C2H5Cl, that is chloroalkane, plus H3PO3, phosphorus acid. Whereas in the case of PCl5, we had gotten POCl3, phosphorus oxychloride, and hydrogen chloride. With SOCl2, the reaction was unique in the sense that it gave us HCl and sulfur dioxide, and both of them being gases, the chloroalkane prepared over here by this method is almost pure. Next is the esterification reaction. So we had CH3COOC2H5 plus water. So if you remember, this reaction is reversible and we carry it out in the presence of a concentrated acid. So these were the properties of the OH group as studied in the case of alcohols. As discussed in the previous video, carboxylic acids have a combination of a carbonyl group and a hydroxyl group, because of which they are called as carboxyl, that is a combination of carbonyl plus hydroxyl group, right? And that is what gave us carboxyl group. So they are able to show some properties of the OH group. Now based on the same, so that means I'm going to remove the OH from the carboxylic acid and try writing the reactions now. Try it yourself. Okay, so you will have, okay, we are taking a general carboxylic acid, so we will have it as RCO, see this part, and Cl. That means you are getting an acid chloride over here. Yes, that gives you a good idea about how to go ahead with the other reactions. Please try it. You would like to tally your answers, what you have written, RCOCl. So in each case it is acid chloride. You could also try writing the same reactions by replacing the R with any alkyl group. So you could take CH3 COOH over here, and then try writing the reaction. So you're going to get CH3COCl, that is an acid chloride, ethanoyl chloride. The word here is, so CH3COCl. How am I going to name it as? So CH3CO, there are 2 carbon atoms in the chain. So eth, right? And then it's a saturated compound, so ane. And then we have the functional group C double bond OCl. And what functional group is this? Acid chloride, which according to the IUPAC system is written as oil chloride. Yes, not OIL, it is OYL. But because this is beginning with a vowel, we do away with the E and we will write it as ethanoyl chloride. Yes, these will be 2 words, right? So same way, you can try replacing the R by, say, another alkyl group, maybe C2H5, and form the product correspondingly. Easy to understand? Okay. Now let us extend our reactions of the OH group to other 2 reactions over here, that is acids on dehydration with phosphorus pentoxide. Now as the name clearly indicates, we are carrying out dehydration. So I have got 2 molecules of acid over here. This is one molecule, this is another molecule. Please remember that they are not connected. No, that will be wrong. These are 2 molecules. So I could have also written this reaction simply by a 2 over here. Both are correct ways. It's just that it is easier for me to represent it. See, I'll get rid of the water, and what am I left with now? When we are getting rid of the water, RC double bond O, RC double bond O. Now there's this oxygen. To whom does this oxygen belong? Now this oxygen is the connecting link between the carbon of the 2 acids, and we have our product over here. This is formed by dehydration of an acid, hence it is an acid anhydride. Right? Now what do you have to do? You have to try writing the same reaction with CH3COOH. Go ahead. CH3COOH, CH3COOH, and I am going to do away with the pyridine. Please write the products of this reaction. P2O5, heated dehydration. What will be the product form? Yes. Again, how do we name it as? It's an anhydride from ethanoic acid, hence ethanoic anhydride. Simple. And what will be the structure? CH3CO, CH3CO and O, and of course water is eliminated. Easy. Now how about carrying out this similar reaction with CH3COCl in the presence of pyridine? Yes, in the presence of a basic catalyst. So when we carry out this reaction, so if you notice over here, I've got an carboxylic acid and I've got an acid chloride over here, and I've got a base. That means the base will help me to get rid of the acid over here, and I am left with CH3CO, CH3CO, and O becomes the connecting link. So again, we are getting an acid anhydride as our product, as can be clearly seen over here, and of course HCl. I hope you know how to name this product. We did it just now. Are you writing down the notes? Trust me, organic chemistry without writing will not make sense. You may understand it while watching the video, but when it comes to writing the reaction, you will again find yourself a bit lost. So better, why not write it while watching the video? The next property is acidic character. Oh, acidic character was the first thing that we should have done because we are talking about carboxylic acids, right? But it's the easiest thing. So let's go ahead. Why it's the easiest thing? Because we are going to correlate it to what you've already done about acids. We know that the general characteristic of any acid is that it reacts with an active metal, for example, sodium, potassium, calcium, magnesium, to liberate hydrogen as a gas, which can be tested, right? How do we test hydrogen gas? I hope you all know the test for hydrogen. Second property of any acid is it reacts with a base or an alkali to give us salt and water, right? Third property of an acid is it reacts with carbonates or bicarbonates with brisk effervescence to release carbon dioxide. So just add vinegar to a pinch of baking soda and you will see that brisk effervescence, that's carbon dioxide, right? Acids turn blue litmus to red. These are the general characteristics of any acid. So carboxylic acids are one set of organic compounds which are able to show all of the above characteristics. And why is it so? It's because of this acidic hydrogen that is there, which can be removed, which can move out of the carboxylic acid in order to be replaced by a metal, right? So let's get started in completing these reactions. So RCOOH plus Na. Would you like to give it a try? Okay. RCOO, the hydrogen gets replaced by sodium and H. But when I write a single H, that means it's a hydrogen atom. Can an atom exist independently? No. So that means I will have to write it as 2 over here. That means there are 2 molecules of the carboxylic acid involved, 2 molecules of the sodium salt formed, and so 2 Na participating over here. So if you notice, hydrogen gas is eliminated. Easy. Now try writing the same reaction with a specific compound. So let's say CH3COOH plus Na. Or maybe just give it a try with potassium. Also remember that your carboxylate part, this is negative, positive. Negative means it has a valency of 1, right? My potassium also has a valency of 1. So if I form the compound, this is the crisscross method and we will have CH3COOK. If I have to form a compound between carboxylate and aluminium, what will be the formula of the compound? Think again. So this is 1. The valency of aluminium is 3. So I will have CH3COO crisscross whole thrice aluminium, right? This crisscross method has been dealt in detail in the videos that I have shared on the channel. In case you are confused, please make yourself comfortable in this topic. It's very, very easy. And it is not surprising that many children, even at advanced stage, struggle with writing the formula of an ionic compound. And it's okay. It's okay to go ahead with your learning rather than to keep thinking that, oh, I don't know. If you make an attempt, you will definitely get it. Done? Is it done? No, I cannot leave hydrogen as H. It has to be H2, right? So 2, 2 and 2. Make sure that you balance the reaction over here. Yes, most of the reactions in organic chemistry we write it as skeletal equations, but just to make it clear to you, that is why we've balanced it. Okay, now try your hand at completing these reactions. So carboxylic acid plus magnesium, and let me change the acid over here. Let me write it as CH3. Go ahead, complete the reaction now. Okay. Next, we said acids react with bases or alkalis to form salt and water. So, go ahead. Again, carboxylic acid plus sodium hydroxide with strong bases H and OH. R, COONA. If you have done this topic earlier or you want to see how well you can do it yourself, best is to pause the video, write the reactions in your notebook and then play it again to see what are the answers to the equations. Go ahead, try the next one. Then thirdly, we said acids react with carbonates and bicarbonates to liberate carbon dioxide. So, I have got here carboxylic acid plus carbonate. It has to give me carbon dioxide, right? So, RCOONA, that's the sodium salt of the carboxylic acid, water and carbon dioxide. Try completing the other two reactions. Yes, it's a bicarbonate. Please be very careful. Yes, carboxylic acids do turn blue litmus to red. Tell me, do alcohols convert blue litmus to red? Can you recall, do alcohols? Alcohols also show slight acidic character. Do they turn blue litmus to red? Think about it. Continuing with the acidic character, carboxylic acids also react with ammonia to give us ammonium salts. So, we have got a base, we have got an acidic hydrogen over here, RCOONH. Why is it forming like this? Because it is forming an ammonium salt of the carboxylic acid. Interestingly, when we heat this ammonium salt, we get an important organic compound, and that is an amide, RCONH2 plus water. Now, your turn to take the board. Try completing this reaction and also form the product of heating this particular compound. Did you try completing the reaction? Good. So, we have CH3, COONH4, and on heating this gives us, yes, it gives us acid amide. In this case, how am I going to name? Okay, first let me complete it. There is water over here. How do I name the compound CH3 C double bond ONH2? Now, let's see the functional group first. It's an amide, right? Now, look at the number of carbon atoms in the chain. There are 2. So, eth, saturated or unsaturated? It's saturated. It's not. You do not see the double bond between carbon and oxygen. You have to see the carbon chain. This carbon chain is fully satisfied. Carbon with 1, 2, 3 hydrogen, C double bond O. Between the carbon atoms, there is only single bond. So, you will consider it as saturated. So, eth, saturated means ane, and then combining it with the amide. Again applying the same rule, vowel. No, we don't cancel that vowel. Why? Because it's going to change my functional group. So, what do? Is I do get rid of this E over here. Ethanamide. Easy? Okay, try naming this compound. Go ahead. How many carbon atoms? Prop, right? Ane, and then amide. Which vowel do we get rid of? Yes, we don't put the two vowels together, so this becomes propanamide. Why don't you try the IUPAC system of nomenclature? Why don't you try some examples of that? There are also videos on the channel which deal with IUPAC nomenclature in detail. There's a series of 4 videos where I have spoken about IUPAC nomenclature. Now, in this video, we've only spoken about acidic character. What are the characteristics, properties shown by carboxylic acid? In the next video, I shall be taking up in detail the acidic character, what it is and how do we define it in terms of Ka, pKa, what is. I'm going to make it very, very easy for you. So please stay tuned, stay connected, come back for more videos. But don't forget, yes please, your pen and paper. Right? See you in the next video. Happy learning. Stay relaxed, stay happy. See you soon. And by the way, don't forget that these charts are also available on the Google site. Pen and paper, chemistry, all flow charts are available on the site. Pen and paper, chemistry, Google site. Yes, please.